The processes of construction and fabrication involve a tremendous amount of human effort, energy, and time. On top of human error, these processes can end up increasing the time and cost of a project, similar to laser cutting. Construction will be most sustainable when buildings are fabricated autonomously as easily as we build models, in which we print or cut the sizes we need and implement those pieces into our design. Taking this thinking into a more manageable scale, a more business model scale, we find Pixel. Pixel is an autonomous fabrication resource that provides limitless creativity to the manufacturing and fabrication processes. Designers, contractors, students, and creative enthusiasts can now fabricate any number of projects with ease and almost no hassle. The time, money, and material saved through using Pixel will leave the stressful tasks to the robotics while you can focus solely on the conceptual. Pixel takes your design from start to finish in the click of a button, completing all your fabrication needs from initiation to large-scale delivery. The team would consist of 4 primary positions: software engineers, chief market advisors, project engineers, material specialists. The rest would be taken on by autonomous robotics. The primary problem in the current method is a separation in the value chain. Materials, tools, assembly, even the design are all found in different areas in different houses, meaning that the user has to transcend and sort of piece all these places together. This can cause stress, especially on those that do not have financial means. However, the market opportunity could basically mend all the competition areas, materials, and robotics together under one roof. This would allow Pixel to house most of the technologies and sort of cost savings, speed, efficiency under its own roof. What this eventually would lead to is an increase in emotion, economics, impact, technology, and the quality of service that none of the other competitors provide. So the design solution is simple. House all the materials, fabrication, delivery methods under one roof, allowing for easily automated delivery, wireless submittal, and then assembly. Because all these activities are being held under one roof, Pixel will be able to make ecological, technological fabrication decisions that are more equitable, environmentally safe, and reduce carbon emissions from the user having to stitch together the disjoint value chain. By replacing human labor with autonomous labor, there's less error, more efficiency, and less hassle for the human user. This would have a tremendous effect on users such as students who have stressful lifestyles and may not have all the methods and means to get around and use fabrication technology effectively. All in all, Pixel aims to eliminate human error in fabrication, reduce waste material, create an understanding for the public, and raise awareness of fabrication alternatives. The audience for Pixel would eventually grow to include all public enthusiasts that understand and want to utilize fabrication technology. This would begin in an educational setting for students where the fabrication technology is already required, and eventually grow into the public realm. This would eventually lead to employment and jobs, expanding creativity for the public, eco-friendly ways of eliminating the inefficient use of materials, and a quicker consumer turnaround. The branding of Pixel would be simple and sleek, emphasizing universal access and the term play through the general public fabrication. The idea of this playful and sleek imagery would be evident in its warehouse and the way in which Pixel delivers its fabricated resource, creating an idea of professionalism through an exciting and playful medium. Because Pixel is looked at as a model that begins to mend a lot of the disjoint value chain, many of its competition could potentially become its partner. Companies such as Universal Fabrication, Blick, and ASU could partner up and create systems in which Pixel and that company mutually benefit off one another. Essentially, this warehouse would operate as Pixel's way of mending this disjoint value chain and allowing a hassle-free experience for the users. The network of this venture would start at the academic level, providing design students of all sorts access to a wide variety of convenient and efficient methods of fabricating their design ideas. Along with students, higher education as well as professors would be put into the mix. The reason why this makes sense is because scholastic settings provide the most room for creative and experimentation and exploration, allowing fabrication to have a strong foothold in the creative and academic arenas. As this venture continues, the hope is to extend this creative library resource to the fields of professional design and construction, putting it not only in the hands of architects and contractors, but also the creative personalities of small venture owners and home owners who want to use fabrication as a means to bring identity and flair to their brand. The venture would want to start small, using schools and scholastic settings as a base. This requires less financial capital, and eventually the company would grow with investors for the equipment and fabrication technology that would eventually create a cash flow of about $1 million a year.